Over the course of a few months and a lot of prototyping and failed designs, I built this. It's a custom built, mostly 3D printed sequential shifter for sim racing, specifically for Xbox. And in this video, I wanted to talk about the final product and its inner workings. So to start, we'll talk about the detent system. So essentially you have this lever. This is what you grab onto shift with. And then that interacts with this part right here. This part rotates. It has these pegs on it, and then there's this spring-loaded system here. So the point of that is to give like that kind of click feeling every time you shift. So this knob at the end tensions the spring for the detent. So you take this off, there's a spring inside. About this big. This just sits in here, and then there's a little part with the like dome head that interacts. It's a bit hard to see, but basically right in there there's a peg with like a dome, and then that sits between these little ridges, so that gets pushed by the spring, and then you can change the tension by just screwing this in more. So this outer part is threaded. Then you have this inner part that sticks inside the this hole, and that interacts with the spring. So let's screw this part on to keep the tension. So like right now, since there's no tension on it, it's like not really like the detent doesn't like. You can see the peg there doesn't really like stay in. So you can add tension back to it and give it that click feeling. So for the detent, I'll just show you some of the iterations I had. So originally my plan was to have it printed and then have like pegs that I would just press it in. This is kind of not a very good idea because when I pressed them, you can see that some of them like weren't straight and some of them also just got deformed, so they ended up being different lengths. Really not the best idea. I don't really know why I did that. But the version I made after, the pegs were just printed with it, which is really what I should have done to begin with. And I just add this lighting just to reduce the amount of filament used. And then, yeah, the problem is you can see here on this one, this peg just snapped off because the layer lines are printing like this. So like it's really easy to shear against the layer lines because like any forces would be parallel to the layer lines. So that's why with this current version, it's actually a printed core, but this plate here is actually milled. So you have this, I think this is just polycarb. This is just milled as one piece with the plate and the pegs. So it's much stronger than the print. You don't have the issues with like layer lines and stuff. So I haven't had any issues with pegs snapping off or anything. And then for rotation, like for shafts, basically I don't really run any bearings on this. It's really just like printed shafts that are just round, and they're all dead shafts, so they're all just bolted directly to the plates. Like you can see here, this shaft is bolted. The shaft for here is just bolted, and then just using spacers for everything. For this part, for the lever, the spacer basically is the torsion spring on this side. And then for the detent system, another important thing to note is that you have this claw mechanism. So it has the two arms on the top and bottom that interact with the pegs. The thing you'll notice is that if I shift up, the claw will go up. It's able to move past down, and it actually goes over the pegs. So if you see here, I don't really know how to show you this, but like that, and you can see it passes over. So basically, the clamp, there's actually a spring here. You can see it's just a normal compression spring right in there. So that keeps it pushed down against the lever arm because the rest of the lever sits over there and it's behind the clamp. So you shift and it can actually come up, get pushed up away from it, up away from the lever, and then the spring will push it back down. And then so that just, there's just a hole in this that goes around in the claw that just sits around the shaft there, and to make sure it doesn't like flop around, there's just a secondary peg. Right, it's pretty small, but it's just a peg right here. So this is attached to, it's just printed with the lever arm core, and there's just like a wide slot for it to sit in. So then I also just add a rubber band here just to add more tension in one direction. So in order for the handle to recenter, there's a torsion spring that pulls it back to center. So it's right in there. You can see the torsion spring wound up, and then one end of it sticks into the slot in the arm, and you don't need to worry about this. Yeah, just don't worry about that. Like, yeah. And then so this sits in the slot, and this helps. That's what interacts with. That's what attaches it to the lever arm. So when you pull back, that's what pulls it forward, or when you push it up, it pulls it back down. And then the second arm is a bit harder to see, but essentially you can see kind of down in there. There's like that little. It's pretty hard to see, but down there's like that little cutout there. I'll show you a picture of the CAD here. It's opened up, so it's easier to see it. The other end of the arm sits in there, so that's what attaches it, to the wall of the shifter. One kind of design flaw with this is that since it needs to spring both forward and back, you're relying on essentially the default deflection angle, and for it to be exact and to recenter to it, which is not usually how you'd be using a torsion spring. Like, for instance, if you've been on a plane, the seat belts in there use a torsion spring, but they only need to spring it back. You only pull the lever one direction, so it only needs to spring it back to closed for one direction, so it can start preloaded. This I can't preload it because it has to, because there's nothing, it's not going against a hard stop to set it back to its neutral position. So some issues I had with that is that when I bought the torsion spring, it wasn't exactly at 90 degrees, so I had to make some adjustments because it wouldn't recenter exactly how I wanted it to. So it's like, that was one thing to keep in mind about. Next, let's talk about the clamp system. So the clamp, it's really just a printed core, so it's just PLA plus, and then this threaded part. So this has like the handle, you rotate that, and this clamps then on the table, so like your desk would like sit between here. And this part is actually milled on a CNC. So this is I think this is FR4, which is kind of like I think it's like fiberglass and reinforced epoxy laminate. And then the reason I have this is because before, with my older version, so I can show you the version I had before, this is one where the whole thing was printed out of PLA, but you can see it's kind of bent a bit, and when I try to clamp it against the table, the amount of force I was applying into it would just like keep on bending, and it just wasn't able to secure it against the desk anymore. So these FR4 plates on the outside prevent it from bending, which, you know, maintains its ability to clamp against like a desk or something. So this board is actually stripped out from an Xbox controller that I bought off eBay. It was broken, so I got able to get it for cheap. The reason I needed an Xbox board and couldn't just use it as a USB device was I was planning on using this with my Xbox, and how Xbox controllers work is that the board has a certain protocol that the console can recognize, so it will only allow connections to an Xbox controller. So I wasn't able to just make a USB device and just have it act as an Xbox controller, because the console wouldn't be able to identify that as a controller. So I had to go with getting an actual board. So basically, a lot of the buttons are stripped out. I stripped out a ton of stuff. So like the sticks, these are where the sticks would normally connect to. I took the sticks are like, they're just like, I just took them off because I don't need them. Buttons as well. The D-pad normally sits around here, or yeah, D-pad sits around here. I took that off. Don't need it. Essentially, the only buttons I need are like the right bumper and left bumper buttons. If it would be any buttons, it's just those are the default bounded buttons for shifting and in the sim racing game that I was planning on using this with originally. But I could rebind them to anything, so theoretically they could be different buttons, but I decided to just use RB and LB. So to go into more detail, I'll take the board off. Okay, so here's the board in more detail. So here's the back of it, you can see. So you see these 4 wires here. These are soldered to the board, to the leads where the for the LB and RB buttons. And so how the shifting actually works is that when you shift, there are actually 2 limit switches that get engaged. So there's one that sits right, you can see the top one right there. It's a little bit hard to see, but right in there. So the switch faces on the bottom side. So the top of the lever arm, or the base of the top of like the part that sits down there, the straight part, that pushes up on it. So you can hear that quiet clicking. That's the limit switch getting clicked. And then there's one on the bottom as well. This is a bit easier to see right there. It's just a printed mount, and that bolts in. And then, so the wire's wired to those limit switches. So basically, since they're soldered to the board where the for the RB and LB leads, they basically trick the board into thinking that I'm pressing RB or LB. So that's how you get the shifting to actually do something in the game. Some issues I had originally were that since I bought a broken controller, I think there was like drift on one of the sticks. So the right stick, which really controls, basically turns your view in the game, was drifting. So like I thought this was being turned. So it was really annoying when you hooked it up to the game. So what I did was that normally there are normally 2 potentiometers that attach to the stick. So they'll move when you rotate the stick in either this, I guess, I don't know what axis we want to call this axis or this axis, to tell the game how much you're tilting the stick in each direction. So I pulled those off. It still was having an issue. So basically, it's because since there wasn't really, since I stripped the potentiometer out, it wasn't getting like a clean reading for resistance. So I had to solder 2 5 kilo ohm resistors to the bottom of the leads to basically trick it to think it's always reading the 10 ohms across the 2 terminals, and and since it's 5 on both from the middle one to the 2 outer ones, it basically thinks it's centered, so it reads no movement. And then I also did the same to the other stick as well, because I was also having some issues with that. So you can see the resistors there. So then I just have this mount here. So this uses the same bolt holes for these. This is I have like the top end stop for the shift in the bottom one, and then I have the bolt for the shaft for the detent. Those just use the same bolt going to that same hole. So this mount, and then these pegs are tapped, so the holes in the board can have bolts that go through them that will just connect into here. Yeah. That's about all for the shifter. Hope you guys enjoyed. It's a pretty fun project to work on. Not the first time I worked with electronics, but more the first time I did my own soldering and doing electronics at this level, I'd say. Yeah, so it's pretty cool. It's pretty fun to use. So yeah.